All right, this video is going to walk you through the process of converting a position time graph into a velocity time graph. A couple of things that might be helpful before we get started. If you notice on the graphs that you were supposed to copy into your journal, the distance time graph says on the y-axis, distance from starting line in meters. And that's another way to say position. In other words, the position of an object just means how far away from the origin that object started. And if you remember back to yesterday's notes, you should have written down that you always have to define the origin before you can talk about motion. So a position time graph and a distance time graph are pretty much the same thing. It may also be helpful before you try translating these graphs into velocity time graphs to label those coordinates of the points. It's just easier that way when you start to talk about where is your final versus where is your initial position. So let's look at our first example, example number 1. The first thing I would like to point out is that you notice my seconds, which is the x-axis, they're all lined up here. 1, 2, 3, and 4 seconds. So we're talking about the same 4 seconds of time. The other thing I want to point out is you notice on this velocity time graph, we have both positive and negative because velocity is a vector. So velocity can be positive or it can be negative. When will it be positive or negative? Let's find out. Also from your notes yesterday, you should know that velocity is equal to the displacement divided by the change in time. And remember that displacement just means a change in position. How far away from the starting point are you, or from the previous point? So we can say that v is equal to delta position, or the change in position, divided by our change in time. And for this first segment A, we always do our final minus initial, meaning the end of that line segment minus the beginning of the line segment. And in this case, our line segment ends at 20 meters minus 0 meters. So where did we end minus where did we start? Divided by our change in time. This line segment ends at 1 second. So 1 second minus 0 seconds, which gives us 20 meters divided by 1 second, which is equal to 20 meters per second. Now we want to plot that on our velocity time graph. And because this object was moving at 20 meters per second constantly for that entire second, our line on our velocity time graph is actually going to be a straight line from 0 to 1 straight across at 20 meters per second. So this line segment on the position time graph is describing the same motion as this line segment on the velocity time graph. Let's look at the next one. B. Again, we're looking at the change in position divided by the change in time. So at the end of our segment here, 20 meters minus 20 meters, which is where we started at. Our change in time, 2 seconds minus 1 second. That gives us 0 meters change in position because our object didn't move, divided by 1 second, which is 0 meters per second velocity. So back up to our velocity graph, and again, a constant 0 velocity from 1 to 2 seconds. And we're going to draw a straight line across from 1 to 2 at 0 meters per second. The next thing you want to do is to just connect your lines so that you know that's the very next thing that happened. Our third line segment, now we're looking at a little bit different. Now, instead of going up or staying straight, now our line is coming back down toward the origin. So let's see what that does to our velocity. Again, remember it's a change in position divided by change in time. So our ending position for line segment C is at 10 meters, but we started at 20 meters. Well, we're going to subtract them in that order. Where did we end? 10 meters minus where did we start? 20 meters. And then divided by our change in time, 3 seconds minus 2 seconds. That gives us negative 10 meters divided by 1 second, or negative 10 meters per second for our velocity. We know that it's negative because my line is pointed down or back toward the origin. Then we come back to our velocity graph and a straight line across from 2 seconds to 3 seconds at negative 10 meters per second. And again, we'll connect our lines. One more line segment to go. And this one is a steep line. It goes a very far distance in a very short amount of time. So that's another indicator that this is going to be a pretty high velocity right here, this nice steep slope. Our change in position divided by our change in time. Where did we end minus where did we start? So we ended at 40 meters and we started at 10. So 40 meters minus 10 meters divided by our change in time, 4 minus 3, gives us 30 meters per 1 second, or 30 meters per second. We come back to our velocity time graph. We find 30 meters per second and draw a straight line across from 3 to 4 seconds. Last step is to connect your line. And now you have a distance time or a position time graph on the bottom that has been translated into a velocity time graph on the top. Both of these two graphs are describing the same motion, just in a different way. Now let's look at our second example. I'm going to go a little bit faster this time. Remember again that velocity is displacement divided by change in time, or a change in position divided by a change in time. For our first line segment here, our change in position is 20 meters minus 0 meters, but we've only gone for a half a second, so it's 0.5 seconds minus 0. And that gives us 20 meters divided by 0.5 seconds. And when you put that in your calculator, that gives us a velocity of 40 meters per second. We come back to our velocity time graph, and it's only going to be halfway through to 1 second. It's only 1/2 of a second at 40 meters per second. So part A, just this little small bit of a line. Segment B, change in position divided by the change in time. Well, we didn't change position. 20 meters minus 20 meters. Our time, we ended at 1.5 seconds and started at 0.5 seconds. So that gives us 0 meters divided by 1 second, or 0 meters per second for that entire time interval. So from 0.5 all the way to 1.5 is going to be a solid line straight across at 0. And then we'll connect those parts. The next line segment, C, is going up again, so we know it'll be positive. Our ending position is 30 meters. Our starting position is 20. Our ending time is 2 seconds. Our starting time is 1.5 seconds. So we get 10 meters divided by 0.5 seconds, which gives us a velocity of 20 meters per second for just that half-second time interval. So part C, a line right here at 20 meters per second and connect it there. Our next segment, D, is going down and quite steeply. So we're going to be negative, and you can tell that it's going to be a high-ish number because it is a pretty steep slope. So our ending position is 10 meters. Our starting position is 30 meters. And again, it's a very short time. It's only 1/2 of a second. So 10 meters minus 30 meters, and this should be 2.5 seconds minus 2 seconds. It ends up with the same value, negative 20 meters divided by 0.5 seconds. Gives us negative 40 meters per second. So all the way down from 2 to 2.5 seconds at negative 40, just like this. And then connect. The next segment, E, is going up very steeply. So again, it's going to be in the positive, and it's going to be a highish number because it's pretty steep. It's only 1/2 of a second difference. So our ending position is 40 meters. Starting is 10. And our difference here, 3 seconds minus 2.5 seconds, gives us 30 meters divided by 0.5 seconds, which gives you 60 meters per second. Very quick, boom. So we're going to go all the way up to 60, draw a line, and connect it. The next section, F, again, still only 1/2 a second, but we've stopped moving. Our ending position is 40, our starting position is 40. So 40 minus 40 divided by 3.5 minus 3, 0 over 1/2 second is still 0, so 0 meters per second from 3 to 3.5. And our last line segment, going back down, so we're back in the negative velocity. Ending position is 30, starting position is 40, from 4 seconds to 3.5 seconds. Gives us negative 10 divided by 0.5 seconds, which gives us a velocity of negative 20 meters per second. So our last piece is going to go right here, negative 20 meters per second, and connect our line. That's it for the examples. Now you are going to practice on 4 graphs of your own. Good luck.